Hi all, we are Group 3 and College of Hotel Management and we are excited to present on our project Query Flow. We are a group of 5, Amit, Gautam, Aditya, Riyansh and me, Shivan and Anjan. Imagine that you are given with a problem, like a image of a table and you are supposed to run some queries on the table. For that, first you need to create a table inside the database. Then you have to enter all the values inside the table manually. And these things take a lot of time, but our project saves you from all of this. You just need to upload the image of the table to our website and it will create the table instantly. And you can run your queries inside. Apart from the images, you can also run these CSV files and create the tables, which saves our time.
This is the ER model that supports our system. We designed it to handle users, file uploads, session logs, data transformations effectively, keeping scalability and clarity in mind. Now, let's take a closer look at the ER diagram. As we can see here, we have six entities in our ER diagram, namely user, audit log, database, image file, CSV file, and query log. Also, they have six relationships among them. From the ER diagram, it's clear that each entity has attributes which clearly describe it. This is the flowchart of component architecture designed for our project. Our system is mainly powered by three components: MySQL, MongoDB, and OCR Worker. MongoDB is used for logging user data and history, also to authorize the user data and history. MySQL is being used to execute the generated queries or the user queries. It is a crucial component of our project. And coming to heart of our project, Python based OCR worker. We are using this OCR to process image tables using advanced vision models. We are also using CSV parser to parse data from a CSV file to convert it into a SQL query. We know that security is crucial. We use JWT tokens with RS-256 encryption along with refresh token rotation to ensure secure sessions. And each token includes a JWT ID to guard against replay attacks. Here's a quick look at the token generation logic in the code. Our project supports two major pipelines: CSV processing and image processing. Each has dedicated steps for parsing, validation, and type inference, with the final output being executable SQL. Here's how our CSV pipeline works. We first validate the file type and structure, whether it belongs to .csv file or not. And then we move on to inferring header schemas, cleaning up duplicates, and setting empty fields as null. Then our regex based type inference detects integers, floats, booleans, or defaults to text. And then finally, we escape keywords, sanitize inputs, and generate a valid SQL file. Moving on to advanced image table processing. Our image pipeline is where things get really cool. We pre-process the image, deskew, denoise, and adjust contrast. Then we extract data using the Paddle OCR, which is an open source, which handles rotated text and multi-line entries. Finally, we reconstruct the table, maintaining row or column structure, and generate the corresponding create and insert SQL queries. This pipeline gives us a 30% boost in OCR accuracy compared to raw inputs.
Welcome to the demonstration of our SQL Playground project. I'll walk you through the front end of our website, starting with this login page. Here, users can securely log in using their credentials. If they don't have an account, they can navigate to the register page where they can create a new account by providing their username, email, and password. So this is the register page. Here you need to give username, email, and password. And after registering, you can log in from here. Once logged in, users are redirected to the dashboard, which serves as the central hub. Uh, The dashboard features a sidebar for easy navigation, allowing users to access the dashboard's overview or select tables from the drop-down menu. The SQL Playground section enables users to write and execute SQL queries, with results displayed in the structured table format down below. One of the key features of our platform is the ability to upload files such as CSVs or even image-based tables, which are processed and converted into SQL scripts via Paddle OCR. So users can then choose to either run these queries directly or copy and paste the generated SQL code into this SQL query editor below, making any necessary adjustments before execution. Now we'll see how exactly it works. First we'll go with .csv file. As you can see, it generated an SQL query. Now we can give a table name to it. Let's say table 1. Now we have two options. Either we can copy this SQL query and paste it in below, or directly we can insert table. We'll insert table for now. Uh, you can see here in query history that the table has been created. As you can see here also, we can select a table, table 1, and we can remove this table if we need to. For checking, we'll just run this query. Now see, here's the output. Okay, so now we'll see how it works with image. For example, we'll take this. It will take some time to process it. See, after processing it through Paddle OCR, it successfully generated an SQL query in which we are creating table first, then successfully it gave us all the queries to insert into this table also. And here we can either copy this SQL query and make some adjustment according to our requirements and paste it here and run this query, or we can directly run this using this insert table. So for now I am directly executing this. So this table is inserted successfully, and also it got updated in this query history. So for verifying it, we'll run a query here. As you can see, it generated the query output successfully.
Also, we have saved history of queries we have run till now. We can also clear it by clicking this button. And some more features are like we can delete the table directly by clicking on remove table. Yeah, now let's see how the code works in the backend. We've just added a new feature, edit table. Now you can rename attributes name directly into the table. I wanted to make it easy for you to change attributes name without any extra step. Just click edit and you're done. So let's choose a file. I'm taking CSV file. It will take less time to load. We can give a new table name. Let's take table 123.
Now you can see table name got changed in creation and insertion both. Let's give it a try. Let's give as number. As you can see, attributes name got changed. Now let's see the code for our project. Here are the code for front end. We have used React plus Vite framework and libraries for front end, and for back end we are using Node.js and Express.js.
In summary, we have built a full stack platform that can convert raw CSVs and table images into SQL, deliver accurate results with minimal manual work, and scale for real world data workflows. And what are our next steps? That is the future scope. We are going to add support for JSON, XML, and unstructured PDFs data types. Also, we are, we are going to improve multilingual OCR and integrate real-time analytics dashboards.
Thank
Thank
you.
you.